Hello, everybody. We are up to lesson 5 of Unit 5. And in this particular lesson, we are going to talk about something called even functions and odd functions. And what even functions and odd functions have to do with are the symmetry of them. So a function, as it says here, is considered to be even if its graph is symmetric about the y-axis. Okay, so remember the y-axis is the vertical axis. So if it is symmetric about that y-axis, we consider it an even function. If the graph has what we call 180-degree rotational symmetry about the origin, we consider it an odd function. So an easy way to tell if a graph has 180-degree rotational symmetry or not is to literally take your graph and turn it upside down. Okay? If you can turn the graph upside down and it looks literally exactly the same, then that means it has 180-degree rotational symmetry about the origin. So if the graph looks exactly the same when you turn it upside down, the function is odd. Okay? So in this lesson, we're going to look at symmetry of graphs to determine whether a function is even or odd or neither of the two. It is possible that a function is not even or odd. In the next lesson, we're going to look at how to prove algebraically whether a function is even, odd, or neither of the two. And that's what the second ones are. So in an even function, f of x, which is your original function, is going to be equal to f of negative x. So what does that mean? F of negative x literally means to replace x with negative x. So that means to plug into the function, but instead of plugging in a number, you're going to plug in negative x. So it means replace x with negative x and then simplify. If you get the same thing as the original function, the function is even. Okay. And then for odd functions, f of negative x, which again, this is what it means. We explain up here what it means. F of negative x, okay, is the same or equal to negative f of x. So negative f of x means to change the sign of each term in the original function to its opposite. So remember, opposites mean positive to negative, negative to positive, vice versa. Okay? So that's how we prove algebraically whether a function is even, odd, or neither of the two. Okay, so when we look at a graph, we'll look at the symmetry of the graph. When we're proving it algebraically, we'll first check whether it's even or not using what I talk about up here. And if it turns out it's even, then we're done. If it's not even, then we'll check whether it's odd or not. And if it's odd, then great. If it turns out it's not odd, then it would be neither of the two. Like I said earlier, in today's lesson, we're just going to focus on the graphs of functions and looking at the symmetry. So with that in mind, let's take a look at the examples for today. So here we have 8 different cards here of table of values, and we want to determine whether each of these are even, odd, or neither of the two. So the easiest way to do that is to literally graph these in Desmos. So what I did was I input each of these cards or examples into Desmos, and I'll show you quickly how I did that. So for example, let me pull up Desmos here. Okay, here is card J. So here is card J, which is the first example. And the way I did that is on Desmos, if you click on this plus sign in the upper left-hand corner of your screen, you can add a table. And it'll create this table, and you literally put in your X and Y values. And notice it actually plots the points on the graph for you so you can look at the graph. So when I look at card J, okay, we're looking for whether it's symmetric about the y-axis or if it has 180-degree rotational symmetry. So first things first, is this graph symmetrical about the y-axis? And when I look at this graph, this certainly does look like I could fold it on itself over the y-axis. So this graph, when I look at the points, is definitely symmetrical about the y-axis. So we would consider this, by our lesson notes, we would consider this an even function. So card J is an even function, okay? So let's go to card K now. So let me pull up card K. Okay. So again, first thing we'll check is this graph symmetric about the y-axis? Clearly, this is not. So it's definitely not an even function, which means it's either odd or it's neither of the two. So the question is, does this graph have 180-degree rotational symmetry about the origin? Okay. In other words, if I were to turn this upside down, would it look exactly the same? So I'm using an iPad here. So I literally, when I was doing this, I literally took my iPad and I turned it upside down. You could do the same thing with your computer, and it looks exactly the same. It looks exactly the same when I turn it upside down, which means it has that 180-degree rotational symmetry. So per our lesson notes, when that happens, we consider that an odd function. So card K, we would say, is an odd function. Okay? So let's move on to card L. We'll go through the rest of these quickly. So card L. Okay? This graph, when I look at it, it definitely is symmetric about the y-axis. I could take this graph and fold it on itself over the y-axis. So card L will be an even function. So card L will be an even function. Card M, okay, definitely not an even function. It's not symmetric about the y-axis. However, if I look at this upside down or turn my iPad upside down, it does look exactly the same. So this is an odd function. So card M is an odd function. Okay, card N. So card N. Okay, card N is just a horizontal line. And horizontal lines, this is definitely symmetric about the y-axis, which means this is definitely an even function. So card N is an even function. Card O, let's pull that up. Okay. Card O, this is definitely this definitely has that 180-degree rotational symmetry. You can see here, if I were to turn my screen upside down, this would definitely look exactly the same. So card O is going to be an odd function. Okay. Let's go to card P. Okay, card P, this is definitely not an even function. Let's check and see if it's an odd function. It looks like it is. It definitely has that 180-degree rotational symmetry. So card P will be an odd function. And then lastly, let's look at card Q. Let's look at the graph of card Q. Okay, that is definitely symmetric about the y-axis. So card Q is an even function. Again, if you're wondering how I input these into Desmos, all I did was I went to the plus sign in the top left-hand corner of my screen. I clicked on that, and then I clicked on add a table, and a blank table comes up, and I literally just put in the numbers. And the cool thing about Desmos is it plots the points for you as well, so you can easily see whether it has that symmetry or not. Again, if it's symmetric about the y-axis, it's an even function. If it has 180 degree rotational symmetry about the origin, so if you turn it upside down and it looks exactly the same, we consider it an odd function. And if it has neither of the two, then it's neither even nor odd. So that is it for this lesson.